All right, so we'll finish up section 6.5. Okay, some of this we already started yesterday, so you already have this in your notes. But just as a reminder, okay, when you're solving a right triangle, that means they want to know how long all the sides are and how big all the angles are. Okay, in order to do that, there's two different scenarios they could give you. This is the one we did a little bit with in the homework. They'll give you one of the other angles besides the 90 and a side. Okay, the second case, this is the one we haven't really talked about yet. Okay, so we'll look more at that today. So as you're solving these triangles, keep in mind you can use the Pythagorean Theorem. Preferably, it's only good to use that theorem if the stuff you're plugging into it was stuff that was given. Okay, we try not to use stuff that we calculated, because if it's wrong, then you use it. Everything else you calculate with it is also wrong. Okay, and also, all the angles in a triangle add up to 180. Okay, so we can use that fact as well. So the general idea is that there's a side you want to know, there's a side you already know, and you have to figure out the names of those two sides. Okay, and by names, I mean opposite, adjacent, and hypotenuse. Once you figure out the name of the side you know and the name of the side you want to know, that should help you figure out, do you need sine, cosine, or do you need tangent? You don't use secant, cosecant, or cotangent. Okay? Mainly because our calculators don't have buttons for them. So always use one of these three. All right, so we'll do one more problem where they give us a side and an angle to start, and then we'll do one where they give us a side and a side. All right, so first thing I'm going to do is make a picture out of that. And Connor, where can I put the 20-degree angle?
Bottom angle.
The bottom, or you could put it where else? Yeah, it doesn't really matter where you put it because nothing's labeled yet. But if I put it right there, where does the 12.3 have to go now?
Opposite.
Opposite. Okay. A and alpha have to be opposite. So now this is the 12.3. Right. And that means if this angle at the bottom is alpha, the one at the top is beta. And the name of the side across from beta, John, is what? B. Okay, so now we've got everything labeled. Any questions on that? So I'll make my table. And the table, again, it's just a way to organize all the information for the final answers. So we've got 12.3. I'm going to put a box around B because I have to find it. A box around C. And let's see, alpha we know is 20. Beta we can figure out easily, but it wasn't given. So I'm going to put a box around it because we need to find it. And this is the right angle. Eventually, we're going to do problems where we don't have a right angle. Okay? And we're going to do the same thing, find the sides and the angles. But for now, we will have a right angle in every problem. All right, so since you're finding B, C, and beta all separate, you can do any one you want first. I like to do the angle first because it's the quickest. So Jacob, how would I get beta? Yeah, 90 minus 20, because those two angles have to be complementary. So how much is beta? 70. Now that I have beta, am I going to use it for anything in the problem? No. It is right, but I'm going to stay away from it just in case I made a mistake. All right, so now we're going to find B and C. Fred, which one do you want to do first?
B.
B. So we're going to find B. And we're going to go back to what was given, the 20 and the 12.3. Okay, so first thing we need to do is figure out the names of these two sides. The name of the side I know, and the one I want to know. Yeah, this is opposite, and that's adjacent. Any questions on why those are the two sides? All right. So now, we know the names of the two sides. We need to figure out what trig function that is. Tangent. Okay, so we're going to set up our equation. And it's tangent of, what's the angle that I'm dealing with here? 20. Okay, so tangent of 20 degrees equals 12.3, yep. 8. Okay, any questions on why we use tangents? So we've got our equation set up. We only have one variable in it. Now we need to solve for that one variable. Okay. How am I going to get b by itself there? Not by the reciprocal. Yep.
Go back down there real quick.
Well, what we really want to do here is get rid of that fraction. So what could I do that would just get rid of this fraction? Yeah, just start by multiplying by b. And multiply by b. Now you have b times tangent 20 equals 12.3. Now I want to get tangent 20 on the other side. So how would I move that? Yeah. Divide by tangent 20. And we end up with b equals 12.3 divided by tangent 20. Okay, now that we did that, does anybody recognize what happened? Okay, here's your final answer. Here's what you started with. What was in that green box. What really ended up happening to go from here to here? Yeah. Well, we did a little more than that because the b also ended up by itself. Yeah, all that really ended up happening is we switched b and tangent 20. Okay? They just switched places. Okay? And you can do that every time. So if you had something like this, x equals y over z. Okay? That's exactly what I had right here. Something equals a fraction. You're allowed to take the x and the z and just switch places if you want. You can say z equals y over x. You can always switch these two. And the reason why that works, we just went through all the arithmetic why. Okay? So from now on, if we get that kind of situation that happens, I'm just going to switch the denominator and what's on the other side. But it has to be just like this. It can't be anything more complicated than just having 1, 2, 3 things. All right, so now let's type that in and see what we get. All right, so we got 12.3 divided by tangent 20. I didn't close my parenthesis, but it's not important because nothing else was coming after it. So it was the last thing. And we get about 33.79. What side did we just find? B. Okay, now I can't figure out C exactly without a calculator, but I can figure out what it should be between. C always has to be what in a triangle? It has to be the biggest side. So I know C is bigger than 33.79. But I also know that in a triangle, if you add any two sides together, it has to be bigger than the third side. Doesn't matter which two. Take any two sides in a triangle and add them up, and it has to be bigger than the third side. So C can't be bigger than 46.09. If it was, it wouldn't be a triangle. Right, so I've narrowed it down. It should be somewhere between 33.79 and 46.09. If I get a number that's not in that range, something's really wrong. Okay, so now let's find C. We're going to go back to what was given, 20, the 12.3, and now I want C. Okay, so focus on what's in green there. So we've named two of the sides. I didn't name C yet. What's the name of that side? That's hypotenuse. Okay, so from the perspective of the 20, we want to know the hypotenuse. We already know the opposite. So which trig function has what we know and what we want to know? Sine. Opposite over hypotenuse. Okay, so let's set that up. Let's see. Okay, so the sine of my angle equals, what side is opposite the 20? 12.3, and the hypotenuse, C. Okay, this is the same kind of situation we had last time with the variables in the bottom. So can I switch the C and the sine 20? Yeah, I can go through all the arithmetic again if I want, or just use that shortcut. And it saves a little bit of work. Okay, so let's check that. And remember, we said it had to be somewhere between like 33.79 and I think it was like 46 or somewhere around there. Okay, and we get 35.96. Okay, another thing you could check is that the biggest side should always be with the biggest angle. The smallest side should always be with the smallest angle. If they're not across from each other, then something went wrong. Now, what's another thing I could do to check A, B, and C? If I could try the Pythagorean Theorem and check, does A squared plus B squared come out to C squared? Or close, okay, because we rounded things off. If it does, then that's a good confirmation you did it right. If A squared plus B squared does not equal C squared, either you checked it wrong or one of your original answers is wrong. Right, so that's the case that we did yesterday. So for those that came in, you didn't really miss anything. That's just a review from the first type. All right, so now we're going to look at the second type. So the second type's a little different. This time what they're going to do is they're going to give you two sides. Okay, it could be any two sides. It could be a leg and a leg, or it could be a leg and a hypotenuse. Okay, it doesn't matter. So let's sketch it first. Did they tell me what side has to be A and B?
No.
No. So I don't know exactly where the 6.1 is going to go, because it says the hypotenuse and the leg. So that's the hypotenuse and the leg. How do I know the 12.7 has to be the hypotenuse? It's the bigger side. If they're telling me they're giving me a hypotenuse and a leg, well, the hypotenuse has to be the bigger one. Okay? So that's definitely going to be C. And as far as where you want to put 6.1, you could put it right here. And you could call it A. And we'll call the bottom B. So the angle that's across from A, what do we call that one? And across from B? Beta. Okay, so now we've got our diagram. Let's make a table. All right, so A we said is 6.1. B we don't know. C is 12.7. Okay, alpha we don't know. And beta we don't know. So in this problem, you can't just add up two of the angles and or subtract from 180 this time, because you're missing both of them. But there is something else you can do here that we didn't do before. Anybody see what you can do first here? And I'm okay with doing it this time, but I wasn't okay with doing it with the last type. Yeah?
Pythagorean theorem.
Yeah, I'm okay with the Pythagorean theorem this time. How come?
They gave us both sides.
Yeah, they gave me everything. Everything I'm going to plug into it is given. So let's use the Pythagorean theorem and we can get b. So a squared plus b squared equals c squared. Okay, I'm not even going to do these numbers out yet. I'm just going to solve it the way it is. So how would I move 6.1 squared to the other side?
But, no,
Subtract
subtract.
it. If you want to do it out, you can, but I'm going to hold off on it for now. So I get b squared equals 12.7 squared minus the 6.1 squared, but that's equal to b squared. So what's my last step to get b? Yeah, take the square root of all of that. Now we need to type it in. Okay, we have to figure this out. Okay, but a lot of times that's how I do it. I save doing out all the work till the very last step like that. And now I'll type it all in one step. And also by doing it this way, I didn't round anything off, okay, as I went. If you take like 12.7 first and then square it and say, all right, I'll call it 161.3, then you've already rounded this answer off. And then you're probably going to do the same thing with 6.1. You're going to round it. And then you're going to subtract it, take the square root, and then round it again. So now you've rounded 3 times in the same problem. So your answer is not as accurate. Okay, if we type it in this way, we're going to round 1 time, and that's it. So square root of 12.7 squared minus 6.1 squared. Okay, so b is about 11.14. 2 decimal places is generally good enough for this kind of stuff. Okay, so we've got b. Now, am I going to use b to find alpha? Nope. Am I going to use b to find beta? No. I calculated it, and even if it is correct, it's not an exact number. It is rounded. So we're going to stay away from using it, and we're going to use 12.7 and the 6.1. Doesn't matter which angle we start with, but let's do beta first. Yeah, so this side would be adjacent. It's the side that's right next to beta. And how about the 12.7? It's hypotenuse. What trig function has adjacent and hypotenuse in it? Cosine. So let's set this up and see what happens. So I get cosine of beta equals adjacent over hypotenuse, 6.1 over 12.7. What's different about this? Yeah, what? Okay, so both numbers in the fraction are, or both the top and the bottom of that fraction have numbers in it. So where's the variable? Denver?
Beta.
Yeah, beta. And beta is the argument to the cosine function. So the variable is inside the cosine function. It's not on the other side where it normally is. So that's different. Anybody know how we get beta by itself here? Well, remember, this isn't multiplication, right? This is the thing that's being plugged into cosine. Kind of like if you wrote this. Even though you have an x right next to a square root symbol, you're not multiplying the square root symbol times the x, right? That's not multiplication. You're taking the square root of x. Like right here, you are taking the cosine. So we can't divide by a word or a function. The way you can get rid of a function is with another function that cancels it out. Like if you wanted to get rid of square rooting, you would, what's the opposite of square rooting? Squaring. That's another function that cancels out the square root function. So there has to be another function that cancels out the cosine function. But we haven't talked about it yet. You think secant?
Yeah.
That's the reciprocal of it.
That negative cosine.
So it has something to do with that negative with the cosine. Does anybody know the name of that? Yeah, it's called the inverse cosine. All right, so what we had, we didn't use that. I think we used beta. So we have this right now, and we want to cancel out cosine. Okay? And the way we're going to do that is with what's called inverse trig. Okay? The opposite of cosine. Okay? It's called inverse cosine. Okay? And just to show you how they look when you write them, those are what the inverse trig functions look like. First one is inverse sine, inverse cosine, and inverse tangent. And you have buttons for them on the calculator. And the way you press them is you press second and then sine, or second cosine, second tangent. Okay, another way you might see them written is this way. I generally don't write them this way. The calculator usually doesn't, well, no calculator I know of does it this way. But if you look at some textbooks, they write it this way. This means exactly the same thing. Okay, but these are what we're going to stick with in this class. Okay, and just to kind of make it clear how these things work. This isn't an inverse function. That's just regular sine. That does not mean sine times 10. Does everyone understand that? Any more than you can do this. You can't take a function and multiply it by a number or a letter. You can't say, what's the square root times the number 2? Square root of what? You've got to tell me something to plug into the function. Same thing here. This is the thing you're plugging into the function. So if you just wrote this and said, oh, I want to take sine and multiply by 5. I can't do that. Sine of what? You've got to put something in here, just like you do here. Okay? And it works the same with inverse sine. If I said to you to take the inverse sine of 0.5, this isn't multiplication. This is the thing that's getting plugged into that function. Okay, but this is not multiplication. All right, so let's go back to our problem and see if we can finish it up. Thank you. So I've got the cosine function. What function cancels out cosine? Inverse cosine. Now remember, you can't multiply by a function. What you can do is take, like when we had something like this. I wouldn't say in that equation, multiply both sides by the square root. You could say, take the square root of both sides. Okay, just like this. Same thing here. We're not going to multiply both sides by inverse cosine. You can't do that. But what you can do is take the inverse cosine of everything that's on the left, and I'm just going to squeeze it in. Take the inverse cosine of everything that's on the right. And when you do that, inverse cosine and regular cosine cancel out. So what's the only thing I'm left with on the left-hand side? Just beta. And now I need to type all that in on the right-hand side. Okay, so first thing you want to make sure of is that you're in degrees. Okay, and we are. So I'm going to do second cosine. 6.1 divided by 12.7. Okay, so it's about 61.29 degrees. So inverse cosine is always used when you want to find an angle. That's it. Anytime you use inverse cosine, you're looking for an angle. Okay, any questions on that? Okay, so on your calculator, if you press second one of the trig buttons, okay, if you type in something that's inverse trig, like, let's do this, inverse sine of 0.6. That answer that I got right here, that is an angle. That is 36.9 degrees. It has nothing to do with this problem, but that's what it is. Okay? So inverse trig is always used when you want an angle. Let's do, did we finish up? Let's get alpha. Okay, so I want to find alpha. I'm going to go back to the two sides that were given. What trig function am I going to use this time? Yep. Yep. Let's see, yeah. Yep, we're going to use sine because what happens now when you switch your perspective, you're not standing at beta anymore. Now you're standing at alpha. So this is now opposite. And that's adjacent. So the sides switch name. They switch names. So sine is opposite over hypotenuse. Thanks. Now we'll find alpha. So the sine of this angle is opposite over hypotenuse. 6.1 over 12.7. And what am I going to do to each side to get rid of sine? And what's the word I'm looking for? We're going to, no, not plug in, take. I'm going to take the inverse sine of what's on the right. And if you're kind of smart when you write it down, if you just leave a little room here, then you don't have to squeeze it in as much. And then take the inverse sine of what's on the right. Inverse sine and regular sine cancel each other out. And type that in, and that's your answer. So if you use the graphing calculator, you can just bring up the last thing you typed in and just change that, if that's faster. Right, so we get 28.71. And a good thing to check is add those numbers up and make sure they add to 180. They should, and they will. Okay. If the angles don't add to 180, you did something wrong. Yeah.
When you find beta, which is cosine, inverse cosine, so 4.7, gives you the answer. If you just add a negative 90 and then take the absolute value, it's the same thing.
Yeah.
It's just a quick way to.
So you can subtract that number from 90 and get this answer a little faster that I just got. But why do you think I would be careful about subtracting 61 from 90? Right. If you found 61, well, you did find 61. If you got it wrong, then you automatically get alpha wrong too. Okay. So the way I showed you, you could have made a mistake with one of them, and it wouldn't have affected the other one. Okay. So on a short answer question, that can help you because you might get credit for 1 or 2 parts just because you make a mistake on one thing, won't mess up anything else. Okay. All right, so we talked a little bit about inverse sine. I didn't practice with inverse tangent, but let's say on the test you had a problem that said, find the inverse tangent of 1.3. Okay, all you have to do to type it in is you press second, tangent, 1.3. The answer is 52.43 degrees. Now I can do this in radians too, just switch the mode. Okay, if they wanted an answer in radians, just change to radians and type in exactly the same thing. So the inverse tangent of 1.3 is 0.92 radians, or 52.4 degrees. Sometimes what they do is they'll give you something like this. Find the inverse sine of 0.5. Okay, and they'll list all the answers in radians. Let's say pi over 3, pi over 6, pi over 2, and pi. Let's say those were the choices. Now, if I do this in radians, which the answers are in radians, all of these are weird decimals. Okay, maybe we recognize pi, that's 3.14, but all the other ones are very strange decimals. Okay, looking at the number 0.52, honestly, off the top of my head, I don't know which one of these it is quickly. Okay, but one thing I can do that sometimes is helpful is get the answer in degrees first. See if you get a nice answer. And if you do, then change it to radians. Okay, so I'm going to do the inverse sine of 0.5. And I get a nice answer, 30 degrees. Now, what do you multiply 30 degrees by to change to radians? Pi over 180. 30 goes into itself once, and 30 goes into 180 6 times. Now I can see it's pi over 6, and that weird 0.52 number I got was actually pi over 6. So this wouldn't come up when you're solving a triangle, because when we're solving a triangle, it's usually in degrees. Where this kind of thing would come up is if they just gave you a separate question on the test like this, and they said, find this, and they list all the answers in radians. A lot of times I do it in degrees first, and then convert it by hand so I can match it up. Okay? Yeah, good.
Isn't the inverse of a trig function just another trig function? So like the inverse of sine would be just cosine, right?
That's a cofunction, sine and cosine.
Oh, I thought that cosine is the opposite of a sine.
No, it's called a cofunction. So there's different relationships. There's cofunctions, sine, cosine, tangent, cotangent, secant, cosecant. There's also reciprocal functions, where you flip one to get the other. That's like sine and cosecant, cosine and secant, tangent and cotangent. That's where you flip one to get the other. And then there's inverse trig functions. So this is new. Yeah. Okay. So any questions on that kind of problem? Yeah.
It's not about the problem, but are there going to be like inverse cosecants and stuff?
You can do inverse cosecant, inverse cotangent, and inverse secant, but we're not going to look at that yet.
All right.
It's not that hard to type in. It's kind of like typing in secant on the calculator. You have to do like 1 over. It's kind of like that. It's a little different. Yep, it's a good question. So anything else on typing in inverse trig functions? Just typing it in and getting the answer. Okay, so you'll have some problems on the test where it's just find the inverse trig function, and then you'll have some like this, where I give you a problem and you have to use inverse trig as part of the problem itself, like example 2. Okay, there's one of these on the test. That's another one with solving with two sides. It's really just like the one we did, so I'm going to skip over that. All right, so this is finding the 6 trig functions of an angle, which we don't know. And the coordinate 2, 3 is on the terminal side of the angle. So, might help to make a picture. I'm going to graph the point 2, 3. And it says that's on the terminal side of the angle. There's the terminal side. Where do I put the initial side? They didn't tell me where to put it. Yep.
It would be the mirror or the reflection of it around the x-axis, right?
Yeah, we always put the initial side on the positive x-axis. So the angle they wanted me to draw is right there. The terminal side goes right through the coordinate 2, 3, and the initial side always put on the positive x-axis.
So no matter what, where it starts, still be the x-axis.
Yeah, it's always on the positive x-axis. Now, I want to find the 6 trig functions of this angle. And what I'm going to do is I'm going to start by just going like that. Okay, because does it matter what size triangle I use when I'm finding a trig function? No. I could make a triangle here. I could make one here. All those triangles in blue are all similar. I'm just picking a small one